Hey y'all, welcome back. Today on my bench I got a PM645 integrated amp. This is a little bigger cousin to the PM640 that I did a while back. I actually have two of these. I got two 645s. One's in black face and one is in silver. So I'll do this one first. I don't know what's wrong with it, if anything. Well, I do know, look at this. This is pretty typical for these Harman Kardons of these years to buttons, and they get lost, you know, they fall off and get lost. But let's try this out. I don't know if it works or not. Okay, there we go. Well, you're getting distortion on the left side. Phono amp noise. So we got the usual scratchy pots, dirty switches. It sounds like we have a distortion coming out of the left channel. Maybe we should scope it to see what's going on here. Before we do that though, let's have a look at the back. Phono input, tuner, video, CD input, 2 tape loops, and 2 sets of speakers, 2 courtesy outlets, pretty standard. This thing looks like it's been caved in here, it's been hit. This is all bent and pushed in. So I'll have to straighten the back panel. It's all caved in here. Looks like it took a hit from something. Thankfully there's no printed circuit board on this side. Otherwise it would be broken, but we'll have a look at it. So just a quick look at the scope here. I'll turn it up full power and you can see it clips evenly both sides, both channels clipping. There's no distortion. So maybe it was just my ears playing tricks on me or my lousy bench speakers, but it seems okay. Doesn't look like there's any problems with the amplifier. I'm still going to have to go through and check a lot of things like capacitors and whatnot just to make sure. A lot of dirt and cat hair in here. I'll have to clean all that out. But yeah, it sounds okay, I guess. And I guess I need a new speaker on the left here because it sounds terrible. It looks like things are knocked out of whack here though. It looks like the front panel's been maybe put on wrong, or the headphone jack does not line up with the hole. There it goes. Pops out. Somebody had this off maybe and didn't put it together right. But we'll deal with that. We'll deal with the knobs. We'll deal with it cleaning up. It's filthy. This one's bent, so we'll do a little clean first. Alright, so I got the dust blown out of this thing, and I started giving it a good visual inspection, and I noticed one thing that's a problem. A couple things, 2 things that are a problem actually. First one is some of these capacitors have started leaking. There's 2 types of capacitors in this amplifier. There's the standard TK electrolytics, and they use these TKs, all the green ones, quite all over the place, and they don't seem to be a problem. The ESRs on them, not bad, but not great either. I think If I really look hard, I'll find a few that have failed. The problem is with the blue capacitors. There's blue capacitors all throughout this, and these are audio spec capacitors. And if I look on the phono board, for example, there's a number of these that are leaking. They got stains around the printed circuit board. Let me see if I can zoom in and show you an example of what I'm talking about. Just hang on. Alright, so I'm zoomed in on the phono preamp stage equalization board, and I don't know if you can see it here. For example, this capacitor, you can see there's a stain around the lead, and this lead has a little bit of corrosion on it. There's another one down here that's even a little bit worse. It's in the shadow there, you can't really see it very good, but it's got the stain around on the PCB board. And this one's leaking, this one's leaking, this one's leaking, and I think they're all pretty much leaking. You'll see a dark stain. That's from the electrolyte, leaks down, and then when you get the corrosion, like this one's really badly corroded here. When you get the corrosion happening on the wire, you get that green fuzzy stuff or white fuzzy stuff. The capacitor is shot and it should be replaced. See, here's another. You can see that there's staining around each lead, and then there's corrosion. So these capacitors are done for, and they need to be replaced. And I'm not just going to spot replace them. I'm going to replace all of the ones that are the same brand. And I think I'm going to also replace the TK caps as well, because they've been a problem for me in the past. With a lot of the other HK gear, I've had problems with the TK caps. Like I've done some testing on some of these. They're okay, but just to prolong the life, I think I'm just going to get rid of them. They're cheap, and why not? The second problem this amplifier has is cracked solder joints. I'll flip it over. If I can zoom in, you can see with me. So this area here is the power amplifier driver stages, let's say, and amplification. There's a lot of heat in this area consumed by these transistors, and a lot of these joints, solder joints, are cracked. Some of them are cracked to the point where they're probably starting to get intermittent connections. If I wiggle some of these transistors, I'm sure I'll see the legs be wiggling too. Let me see if I can do this. No, well, it's not far along, but so I'll have to resolder some of this and get this back in order. And there's spots, other spots that have it too. It's not just here. There's a little power supply section here, and there's some cracked joints here as well. These ones are a little worse off because there's probably been more localized heating. So I'll resolder all of this and resolder this, and that'll fix that up. But first I'm just going to get on with the recapping of this amplifier. And you can see once I pull out the capacitor, when you heat up the solder, it really starts to stink. Like, it smells bad. You can smell that electrolyte. You can see the corrosion on the bottom. It's not severe yet, but it stinks, that's for sure. And you can see the staining it makes on the board here. This is electrolyte. That's not from heat. So I'll clean that up. Put new caps in. Here's another example of failed capacitor. It's on the power LED of all places. There's a little LED above the power switch, and you can see the corrosion. I don't know if you can see that. It's pretty. See the corrosion going on here in the leads. And the other side, this one's actually carried through to the other side, and it started to corrode the solder joint. and it's just turning the solder into a gray powder, and it's starting to eat away at the copper trace, which is also not good. So not much longer that would have failed, and the way this board is printed, the LED would not light. So what I'm doing is I'm removing the electrolytic, and I'm going to put in a chip capacitor, 10 microfarad chip capacitor, and I'm just going to tack it onto the board and be done with it. Stupid capacitor took a crap on the board. Alright, board cleaning. What I usually do when I'm done is I remove the flux, because when you're done recapping and you resolder, there's a lot of flux that's left behind. So I just get a paper towel, an old toothbrush, and some isopropyl alcohol, and I just give it a little bath here. Just pour on a little bit. Not too much. You don't want it spilling all over your bench. If I can get this. Probably about that much. And just work it in. Give it a good scrub. Try and get all the spots between the transistor legs. Removing the rosin flux actually helps, I think, in it helps the backside of the printed circuit board achieve better insulation, because when you get all this crap on the board and it starts to absorb moisture, it can leak. You can get current leakage, and something you want to try and avoid, obviously. So I just keep scrubbing until it looks clean. Get all the spots. I think that's okay now, and just dry it off by dabbing. And you can see all the rosin flux. It picks up all the yellow. And it looks a lot better. And I'll go through again with a magnifying glass. I think I still missed a few joints that probably need touching up, but I did. You can see I did a lot of soldering on this. All the transistors I resoldered, because a lot of them had cracks. Even though they weren't cracked through, they were starting to crack. That's basically cleaning a printed circuit board. And let it dry. So I got it all back together. Just to explain what I did. I did a full recap on all the boards, including the two power supply capacitors, because I tested them. They are about 1,000 microfarads down in capacitance, so I elected to upgrade these to 10,000 microfarads at 50 volts from 8,000 at 45 volts. Exact same physical size, so I decided to go ahead and do that. And now I'm in the middle of doing the bias adjustments. The procedure for the bias adjustment is to, here I'll show you on this. This is the power amplifier, this is the two output transistors. And in between the two output transistors you have your two emitter resistors. They're drawn as separate, but actually they're combined into one package. So there's two resistors in the one package with 3 leads. And test point 1, test point 2, where is it now? Test point 3, test point 4. So you're measuring the voltage across both resistors. That's where the 2 test points point out. And our spec is 33 millivolts at idle. And I've had this on for about 20 minutes now, and I have been letting it warm up, and I'm at around 67 millivolts, so it's almost double what it needs to be. So I'm going to turn it down, turn this down, and then I'll let it settle, and turn it down to 33. Turn it down quite a bit. There, it's at 32 now, and heatsink's heating up pretty good. I think it was consuming more current than it needed to. So let's go over to the other channel and see what adjustment that side needs. And this one is up at around 59 as well, so it's over what it needs to be. And I'll turn this one down to 33. And 34. I'll let that settle, and this will have to cool off now because I think it got a little too hot from the previous bias. So we'll let this settle for another 20 minutes. I'll come back and check both channels and tweak it a little more if it needs, and then we'll call her done, and then we'll do some testing. One more thing I want to mention, the underside of these PCB boards, I found a lot of cracked joints, and I went through and probably resoldered 50% of these boards. Hopefully we got that sorted as well. There's no iffy joints anymore. Alright, it's about a half hour later, and I let this stabilize. This channel here is idling at 32 millivolts, which is bang on pretty much in my books. And then we'll check this one again. If you don't let it stabilize over time, it doesn't turn this one up. This is at 24 right now. Let's turn this one back up to 33. Very good. Just same as the other channel. And I'll let that stabilize one more time. I don't think it's going to go too far. The reason you wait a period of time between adjustments is this heatsink needs to temperature stabilize. Either it has to cool off or warm up to get the bias current correct. And the temperature of this has a lot to do with the voltage reading. If I were to take a torch and heat up these fins, the bias current would go way out of whack because it's compensating for the extra heat. So, very, very good. Let's do a power test. Okay, you're all wired in to do a power test here. I got 8 ohm dummy load, scoped, 1000 hertz tone feeding in. Right now I've got nothing going in. One thing that concerns me is I have a pop when I power the unit on, so let's listen for that. Turn it on, and it's a delayed pop, which tells me it's in the circuits that protect or mute the amplifier. So let's try this. And it seems like it's both channels. Anyways, let's feed it some signal, and I'll investigate that pop later. Shut the speakers off and turn this up. Okay. Should be a clipping there. There's clipping. Symmetrical on both sides. There's no flutter on the power supply rails. Looks good and stable. Right about there, I think. And I got 20.05 volts RMS on the output. We'll just let that cook for a while. Seems like that left channel, well, actually the right channel's on top, so the right channel seems to clip a little sooner than the, I don't think that's a function of balance. Seems like I'll turn it down a little bit. 19.8 volts RMS. So I'm going to let this cook for a while, and then I'm going to pull up the schematic and try to look at this power amplifier and try and figure out why it's popping when it comes on. We might have a DC offset somewhere. Alright, so this has been cooking for 10 minutes now, and this is getting nice and toasty. And this is even warmer. The heat sink for the, I'm going to shut this down. Looks like it did okay. So I switched the speakers on and off. I do not hear any DC thump on those outputs. It's pretty quiet, silent, which is a good sign. So let's try a different frequency here. Let's try it down to 15 hertz. Ten. Subsonic. Subsonic cuts it down quite a bit. Okay, let's try a higher frequency. Let's try 3 kilohertz for, let's see here. Let's see how it does on the high frequency. We're at 8 kilohertz now. 9, 10, 11, 12, 13, 14, 15, 20. It's pretty flat. We're up above 60 kilohertz now. Full power. I don't want to leave it there too long. Alright, I think checks out. I'm going to investigate that pop, that power on pop again, and we'll wrap it up. Alright, I don't know if you'll be able to see this on the camera, but this capacitor here has been changed. And this capacitor is on the input of the right channel. And it's a brand new Nichicon Gold Series audio cap, but the previous cap took a dump on the board here, and it looks like there's electrolyte all over. There's some jumpers here, looks like they're covered with electrolyte, and over here some electrolyte. So I'm going to remove that cap and re-clean that, because I didn't clean that good enough. And I think I have some DC leakage here on these two jumpers. I don't know what they do, but it doesn't really matter. It seems like if you get any little bit of DC current offset here, it'll make a bad thump on the amplifier. So I'm going to pull that cap out again, and I'm going to clean this board up better. Okay, here's a better look at it, and you can see these two jumpers are corroded, and you can see where the capacitor was. I'll try cleaning this out. Might have to remove those jumpers. Kind of a cramped area here. I think this is the part of the problem. Maybe I just didn't clean it good enough. I might have to pull those jumpers because there's crap underneath them. It seems like we're picking up something on the Q-tip. Yeah, that's corrosion from the previous. Let me pull those jumpers out. Alright, I think it's time for me to give you a little bit of an update what's going on here. So far we did a full recap of this amp, and then we did some power testing after. Everything was working good with the amplifiers. I was getting a power on pop on the right channel after the power on muting comes off, and this is a mute line here. I can't see it. There's a mute line here for this channel and a mute line for this channel, and this transistor Q11 switches that Q12. So I've been trying to figure out why the right channel has a pop in the speaker when it comes alive, and the left channel was well behaved and didn't have that pop. And spent a lot of time, a couple days actually, trying to figure this all out. And just to put it in perspective, I started working on this amplifier before Christmas 2020, and you know, during the Christmas day and New Year's, or between Christmas and New Year's, I had put this aside because I was doing other stuff. And now it's January 2nd, and I'm still, this stupid thing is on my bench, and I'm getting frustrated and annoyed. And I'm beginning to think this might be the end of this amplifier. I might just EOL it and just call it a day. And but I don't know. I'm getting pretty frustrated, and it's testing my patience, that's for sure. So what I did to try and find this pop is I went through and I was doing voltage checks, comparing between the two channels. I tested all these transistors. I removed, this is the right channel here, I removed this transistor and this transistor, and essentially that broke the tie between your long tail pair and the input, and the rest of the amplifier, the voltage amplifier section and the output section. And even though these two transistors gone, it was still making the pop noise, because I thought maybe I had, when I replaced this capacitor, I thought maybe the board, well, let me explain this. When I took the old capacitor out, it had leaked electrolyte all over the board and the neighboring components. And I thought maybe, well, since the electrolyte soaked into the printed circuit board, maybe the printed circuit board became slightly conductive and it was leaking current, and I was getting a current leakage through the board that was maybe affecting the biasing of these transistors. So that's why I took these two transistors out and just eliminate the front end from this equation. And you know, after removing those two transistors, this was still popping. So what I was doing is I was testing all these other transistors. This is kind of a unique arrangement. They have your NPN and PNP driver transistors. This is a 2SD667, 2SB647. Those are two common transistors they use for drivers in a lot of amplifier circuits. And if you look, they have them paralleled. There's two of them. They're paralleled with each other. I don't understand why they did that when they could have put one transistor in that had higher rating. But regardless, this is what they're doing. So what I did is I replaced these transistors. No change. I replaced this transistor. I replaced some of these transistors. What I did is I swapped transistors from one channel to the other. I was, maybe I had a transistor that had leakage. I was just grasping at straws there. I tested resistors. Everything tested out fine. It seems when the power comes on, I can apply power to the circuit, and then the 2.5 or 3.5 seconds later the mute comes off, and I get that pop. So what I was doing is I was scoping the this line here is your feedback. I was scoping this line, and it shows a negative voltage. And it's always negative. It seems to drop negative. So I suspect the problem's on the negative rails here, or negative side of the amplifier. But after the muting would come off, it would drop negative, and then it would quickly recover and try and settle and to a zero state again. And it seems like the negative feedback is working that way, because when the amplifier turns on, it tries to recompensate and balance itself back to a zero state. And I've got no offset voltages on either channel before or after the mute. So I'm at a loss here as what's going on. So replacing transistors, I've been swapping left to right channel, everything I can think of, testing resistors. There's really no capacitors here that I've changed that will make that happen. There's a 330 here and a 330 here, and these are just to stabilize the power rails. There's a 220 microfarad here, but this is also just to slow down the frequency response of the feedback, the DC response, I guess. And there's obviously the capacitor at the input of the amplifier, and like I said, I removed these two transistors. That has no effect. The tone circuits are also part of the feedback, which is something I haven't really looked at yet. Right here you have your bass and treble controls, and they are incorporated into the feedback network. And there's a ground here, ground here. It's not supplying any voltages. All it is doing is it's shunting certain frequencies to ground, or allowing certain frequencies to go through. But I'm going to look at this closer. So I've been working on this for 2 days, trying to get this figured out. And like I said, swapping transistors around and everything. So what I decided to do is I decided to give it another bias idling adjustment, because I had actually replaced, I've taken these two transistors and put them on this channel, and then these two transistors and put them on this channel, just to verify that those 4 transistors are okay. And they were okay. And I also took the opportunity to remove the micro washers and replace them with sill pads. So then I did that, and then I said, well, I'll give it another DC bias adjustment. So I hooked up my voltmeter, turned it on, and I left the room for 20 minutes or so. And I came back, and the amplifier was dead. I said, what's going on here? So I looked, the fuse was blown. What? How could that happen? So I looked, and sure enough, the 2 transistors in the left channel, they weren't shorted, but they were melted to mush. Let me see here. Take this. Yes, the 2 transistors that were in the left channel, they're not shorted. They are leaking both directions. So they got overheated. Some thermal runaway. And I didn't expect that to happen. The left channel was working fine. So here I am. I got a pair of new transistors dug out for this morning. I'm going to put those in. But this thing's testing my patience. I don't know. I might just grenade it and throw it away. But yeah, so I tested the driver transistors and they're all good. So that leads me to believe that the problem didn't stem from here or here. Well, obviously there must have been a biasing problem to overheat these two transistors to cause them to grenade and melt down. And when that happened, both transistors melted down and the fuse went. And that was the end of that. So here I am today. I'm going to put two brand new transistors in. I'm going to set the bias up properly, make sure it's good. And what I might do is remove these 4 transistors and replace them with 2 transistors of higher capacity or higher rating. I don't see the necessity of having 2 transistors like that. For whatever reason, Harman Kardon thought it was okay, and they did it, and it worked. And but I think what I might do is take those 2 transistors out and put in a complementary pair. That's something that's a little beefier, maybe something you can attach a heatsink to, and we'll go with that. The problem is these 2 transistors are identical, and they are paralleled. These 2 transistors are identical, and they are paralleled, but these 2 transistors are thermally bonded to each other. And that might be a problem. I could probably thermally bond all 3 transistors together, or did the 2. If I take this one out and replace this one, I can bond these 2 together. I checked this diode here, and I thought maybe that was leaking internally, reverse leakage. So I tested, and my meter goes up to 200-300 megohms, and there's nothing there. Yeah, and then I'll have to take a close look at this circuit here to make sure there's no bad resistors or anything like that. I've got new caps in here and here. That shouldn't be part of my pop problem, the popping on power up. There's something going on with this right here that's causing an imbalance, and then the feedback circuit tries to correct it as it comes alive. Okay, you're probably wondering, what the hell am I looking at here? Well, this as soon as I shut the camera off for my last segment, I found this. This is the thermal biasing diode, and I'm checking for continuity between the diode and the case ground screw, or it's not a ground screw, it's a ground connection. It's a little diode crimped in that little holder there, and that's to thermally bond it to the heatsink. And I'm picking up all kinds of current leakage between the 2, and I don't know if you can see that there, but right at the joint where the wires come out, there was some thermal conductive glue, and not thermal glue, it was that conductive glue, circuit glue. I put a dab of it there for some reason, I don't know why, and I think it's actually causing a shunt to ground, and I'm getting it on both these diodes. Here, I'll check the other one as well. Plug this one in, and what's going on here? Why is my meter not behaving? And this one's going to behave now. But when I move the wires around, let me try this. I don't know, maybe not. But if this is a shunting to ground, this is right in the middle of the biasing circuit, this could be the cause of my problems. So I don't know. I'm gonna have to. What I might have to do is figure out a new mounting solution for this and isolate that tab from the heatsink, and that would be the end of it. Or I don't know what else is I could do. But regardless, I'm going to take this and install it. I'm going to clean it up really good and install it back in the circuit, and then I am not going to secure it to the ground, the heatsink. I'm going to leave it floating, and I'm going to see if my problem disappears with the pop on power up. So I'm trying to clean the faceplate here and the knobs, and it had some kind of a film on it that I couldn't get off. I rubbed alcohol on it. I did everything I could think of. But I think what works the best, and worked for me, is I just use a foaming glass cleaner, like this, in a spray can. And what I did is I just soaked the knobs, or what I did is I soaked the faceplate, and I'll show you on the knobs here. I just soak them down, get them all wet on all sides, and just let them soak for a while. And give it 5 minutes to soak. And then scrubbing with a paper towel should get that yellow mung off these knobs. You can actually rub them in if you desire. You could give them a little massage to get that stuff off, but it seemed to work okay on the front panel. I had a lot of staining, and there's still some staining here you could see, but most of it's gone. And on the top too, it had a really dark film. And I don't know if it was nicotine or what it was, but it didn't want to come off. Okay, wrap this up. As complete as it's going to get. What I did is I did a full recap on the amplifier. Replaced both of these filter capacitors. They were a little subpar. The main culprit with this one were these blue capacitors. There's two types. See them all. These are all of them. Two types, the TK capacitors, they fail on their own over age and heat, but these blue capacitors, they all are leaking. If I look at every one of them, it has corrosion on the legs and has some degree of leakage on the bottom. Well, that one doesn't. That's strange. All these other ones have corrosion on the leads. They all leaked, so they all got to go. Even though they tested fine, they still had to go. So that's the extent of the work that went into this thing. A few other things. This knob was bent. I think it was damaged in shipping, to be honest, because it wasn't the knob and it wasn't the shaft. It was the sheet metal behind the faceplate that was bent. I think it got pushed in. So I had to go in and massage the sheet metal to bring that knob out a little bit, or the potentiometer out a little bit. And now it's sitting a little more straighter. That's not a word, is it? Straighter? But it's working good now. Another thing I did that I didn't mention in the video is I replaced this LED with a high brightness. And I think you can see the difference between the regular LEDs that they had in there. They're pretty dim, see, and then the high brightness, I think these are really hard to see, especially if you're in bright light. You can't even really see that indicator. I didn't change these, I just left them alone, but I thought the power indicator, it was important to have an LED bright enough so that you could see it from across the room that this powered up. The back panel had also been caved in here. I think it took a hit on the speaker connections and it was all pushed in, so I had to take the back panel off and straighten that out, and it looks a lot better now. But all in all, we'll see how this one works, how it performs. This is a PM645, and I did a previous video on a PM640 that I did a full recap on, and I did a listening test on it after, and it sounded terrible. And so I'm kind of curious as to how this one's going to sound as well. I think it has something to do with Harman Kardon's design in putting the tone controls into the feedback loop of the power amplifier. And I think that's what it was that really put me off this amplifier when I was listening to it. It just didn't sound good. It sounded muddy and I don't know. But I'm going to try this amplifier out and see how it sounds. And I got another one of these 645s in blackface that's coming up. I don't know when. I want to do a bunch of other stuff first. I got some tube equipment I want to work on, and I have some really vintage old German stereo equipment I got to bring out and do some work on. I'm kind of itching to get that done too. But for this one's done. A lot of work, a lot of parts went into it, and I don't know. We'll try it out, test drive it, see if it's up to snuff. If it isn't, I might do another video on bringing it back up again. All right, thanks for watching, and take care, everybody.